Okay, I want to pick up where we left off with our 1.5 notes. All right, and we're going to pick up here, right here. So I want to go back over, right here, we had to do the distributive property. Go to distribute -2 times x and -2 times -5. And then 6 times 2 and 6 times negative 0.5x. Okay? And so that's what I want you to do as you look at number 3 and number 4. So why don't you try those real quick and we'll see how you do. Okay, so here on number 6, remember we have to distribute. So 6 times 4 is 24. 6 times negative z is negative 6z. And then you bring this down, right? I forgot my line. Bring that down, bring this down. Okay? So that was parentheses. We had to do the parentheses first. Now we have to combine the like terms on each side. Are there any over here? No. Any over there? No. So now we need to get the variable terms together. Now since this z is over by itself, we're going to move this 6z over there to combine with that. So we look here, we have a negative. We're going to add 6z to both sides like this. Okay? That keeps it balanced. So over here it cancels. So we're left with a 24. Bring down your equals. These are both positive. So you just add that together and you get 8z. We then would have to do the constant terms. We don't have any constant terms, right? So then the last thing we need to do is to divide by the coefficient of the variable. So the coefficient is this number right here. So we're going to divide by 8 on both sides. So that is going to give me 24 divided by 8 is 3. And then over here, the 8 cancels out. So we have z is equal to 3. Okay. All right, let's look at number 4. Now, number 4, we have to distribute on both sides, So distribute here. We have 5w. 5 times -2 is -10. Bring down the equals. Now this is a negative, so -2 times 1.5w is -3w. And then -2 times 5 is -10, like that. So that gets us our parentheses step. Now we need to combine the like terms. So there's no like terms on the left or on the right. But now we got to deal with the variable terms. So just as a guide, let's get the variable terms all over to the left. Right? So we have this one over here. How do I move it across this to be able to combine it with that? You do the opposite operation. So we're going to add the 3w. That cancels it out. So we'll bring it over here as well, because whatever we do to one side, we have to do to the other. Bring that down. That's 8w. Bring down your -10 equals. Then over here, we're also left with -10. Okay, so then we need to do the constant that's next to the variable, because we got to get the constants together on the other side. All right, so the opposite of minus is to add. All right, so that cancels out over here. So we have 8w, bring down your equals, and -10 plus 10, that's 0. So 0 is just a number. Okay, so don't worry about that. Then the last step is we're going to divide. Sometimes that's multiply, but we're going to divide. All right, so you divide by the coefficient of the variable. So that cancels out, and we're left with W. He's so happy that he's by himself. And then divide over here. What is 0 divided by 8? It is 0, just like that. Let me redo that last little bit. Okay, so what we have to do, we have to, right, we're going to get we're on the constant. This constant needs to move over there. So we'll have to add the 10 right here, like that. So on this side, that cancels. So we're left with 8W. Bring down your equals. And negative 10 plus 10 is 0. Then our last step is to divide. All right, so we'll divide right here. Divide by 8. So here, that cancels out. We're left with a W. He's so happy. That equals 0 divided by 8, which is 0. So that's our answer right there. Okay. Now, a couple of things that we have to do is look at a couple of cases where we have special circumstances. Okay? So you'll understand more about that once we do it. Okay, so let's just look at this. Let's approach it like we've been doing. Solving an equation with no solution. Underline the words no solution there. Okay, so what we're going to do is we're going to look and we'll follow our steps, right? There's no parentheses. There's no like terms to be combined on the left or on the right. We do have a variable term, right, to deal with. So remember, we're going to take everything from the right, bring it over to the left. So this is a minus 4x, so the opposite of that is to add 4x. So we'll add the 4x, right? So that's going to cancel. So I'll bring down the 3, bring down my equals. Well, this also cancels over here, right? Now, wait a minute. Did we do anything wrong? Right? We add 4x, add 4x. That cancels, that cancels. But wait a minute, does 3 actually equal negative 7? No, this is not equal, right? So that's not possible. So whenever you have that the left side is not equal to the right side, right? We have this situation where these are not equal to each other. We have what's called no solution. No solution. When having an equation that has no solution, you will obtain an equivalent equation that is not true for any such value, such as, there's an example. But this is the deal. Whenever you've done everything right, and you have like this side is not equal to that side, you have these constants that are left, right? A constant not equal, 3 does not equal negative 7. So that's not equal. So when you have that situation, that means there's actually no solution to this problem, right? This is bad information to start with, so it just doesn't work. There's no solution to this. There's no value of x that would cause this to work out correctly. If we were to put 1 in there, it wouldn't work. If we put 0 in there, if we put 100 in there, it wouldn't matter. There's no solution to this. All right, so I want you to work these two out, and I want you to actually work it out to see how it works, okay? So do 5 and 6. All right, so on 5, are there any parentheses? No. Are there any like terms to be added? No, no. All right, so let's deal with the variables. All right, so we want to take this variable term over there. So we have to do the opposite operation. So we're going to subtract 2x and then do the same thing on the other side. That's 2x and negative 2x cancel out. Bring down your 1, bring down your equals. That also cancels out. All right, so does 1 equal negative 1? No, that's not actually equal. So this one has no solution. So when we do this, I'm going to be looking to see if you have done that part of the math correctly. All right, so then we'll go on to number 6. Number 6, we do have parentheses to deal with, right? So we do 6 times 5 is 30. And then 6 times negative 2v is negative 12v. Then here we distribute negative 4 times 3v is negative 12v. Forgot my line. And negative 4 times 1 is negative 4. Okay, so now we want to deal with the like terms. Don't have any. We want to deal with the variable term, right? So we're going to take this variable term over there. So you do the opposite sign. So over here, that cancels out. We're left with 30. Bring down your equals. This cancels out. Bring down your negative 4. And that is definitely not equal. So the answer is no solution. Okay. Good, good, good. All right, now this time though, we're going to have a different case, different situation. This one has infinitely many solutions. Underline that. So let's look at what happens in this case. Okay, so in this case, we have to deal with these parentheses over here, right? We got to deal with those parentheses. So these things aren't going to change, so we just bring them down like they are. Okay? Bring down your equals. Now we need to distribute. So 4 times 3 over 2. So I want you to use your calculator, and we're going to go 4 times, hit the fraction button, do 3 over 2. Press enter. That gives us 6. And then 4 times 1 is 4. Okay? Now, there's no like terms to be combined, but we need to deal with the variables. So, I forgot this x. That should be having an x on it. So we need to take this x term over to the other side. And how do we do that? We'll do the opposite sign. So in this case, that also is going to cancel out. So we have 4 equals to 4. But this time, it is equal. The variables canceled out, but 4 does equal to 4. So this one is equal. So if you have a result that it is equal, that actually means there's not just one solution. There is infinitely 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 many solutions. Infinitely many solutions. Okay? And that's when these are equal right there. Infinitely many solutions. So this other kind is when they weren't equal. That means you can't find a solution. This one, they are equal, and any value of x would work, right? So up here, no value of x would solve it. Okay? You can't find a value of x that would work here. But for this one, any value of x would solve it. Solve the equation. It all depends on whether it is not equal or whether it is equal. Okay, so I want you to look at doing these two problems right here, number 7 and number 8. Okay, and so we're going to practice using the calculator when we do that, okay? So we're going to go right here, right? We have to do the parentheses first. So half of 6t is 3t, right there. And then half of -4 is -2. Bring down your equals, and then we have 3t minus 2. So there's no like terms, but there are variables we need to combine. So we have this 3t, needs to go over there, so we'll subtract the 3t. That's going to cancel, leave you with -2. Bring down your equals, that'll cancel, leave you with -2. So those are equal. So this one has infinitely many solutions. So any value we put in for t would solve it. 5, 10, 100, doesn't matter. All right, so then let's look at this one. Now, I want you to use your calculator. So 1/3 times 2. If you're not sure what that is, we'll just put it in the calculator. 1/3 times 2 is, we just want the fraction version. It's 2/3. So that's going to be 2/3. And then 1/3 times 9. Right, so let's do that again. 1/3 times 9. That is going to be 3. All right. Oh, I forgot my b again. Sorry about that. And then 2/3 times b is 2/3 b. And then what is 2/3 times 9/2? Use your calculator. 2/3 times 9/2. That gives me just plain old 3. All right. I forgot my line again. Sorry about that. So we did the parentheses. There's no like terms to combine, but we do have variable terms on both sides. So we need to subtract 2/3 b. Subtract 2/3 b. So that will cancel, leave you with 3. Bring down your equals, that cancels, leave you with 3. And there we go. Those are equal, so that means it's infinitely many solutions. Okay. Awesome. All right, so we got a couple more to look at. Okay, so we're going to skip down to example 6, modeling in real life. Okay, so we have a boat that travels X miles per hour upstream on the Mississippi River. On the return trip, wait a minute. and it takes 3 hours, okay? On the return trip, the boat travels 2 miles per hour faster, and it takes 2.5 hours. How far does it travel upstream? Okay, so the distance doesn't change. The distance is always going to be the same, okay? So we're going to use the formula, the distance is equal to the rate times the time, okay? Now, since traveling, like I'm going to go upstream a certain distance, and then I'm going to go back downstream a certain distance. So the distance for each is the same. Like if this was 2 miles, this would also be 2 miles. Either way we go, okay? The difference is the time and the speed at which we traveled. So in this case, notice that right there, they have this set up so that the distance of one is equal to the distance of the other. So the rate times the time for one trip, for the upstream trip, is the same as the rate times the time of the other one, of the downstream trip. Now, the rate and the time changed, but this is still going to set up it to be equal. Okay, so going upstream right here, what was the rate? Well, we don't know. That's what we're looking for. So that's just X. And then what was the time? 3 hours. 3 hours. Now, what was the rate coming back downstream? Well, just 2 miles an hour faster. So if we went X the first time, we're going X plus 2 coming back down. And then the time, since he's going faster, it took less time, like that. All right, so we need to do the parentheses first, and we're going to do a little multiplication. X times 3 is just 3x. Then here, it's in reverse, but we still have to do the distributive property. 2.5 times x is 2.5x. And then 2.5 times 2, that is 5. All right, now I'm out of room, so I'm going to just rewrite it up here. 3x equals 2.5x plus 5. Okay, so I have this variable term. I need to get over there to that variable term. So I'm going to subtract that right there. And doing that, I get 0.5x. Bring down your equals. That cancels out. 5. Now we're ready to divide. Divide by 0.5. 0.5. So this is going to cancel out and leave you with x. Then 5 divided by 0.5, that is going to be 10. So 10 right here, what was 10? 10 miles per hour going upstream. And then, so that's miles per hour, and the time is 3 hours. So that makes a distance of 30 miles. All right, so on number 10, it's going to be just like what we were doing on 9. Okay, but they just give you different numbers. Okay, so on this one, a boat travels 3 hours downstream at r miles per hour. So we're still using distance equals rate. The rate is r miles per hour times the time of 3 hours. And then returning, it goes 5 miles per hour slower. and the time is 4 hours. All right, so going, this time they do the downstream first. So the downstream is the rate times the time. And that's because the distances are the same, that's how we get the equality. So the rate for this one is 5 miles an hour slower. So instead of adding, we're going to subtract. And the time is 4 hours. So it's the rate times the time equals the rate times the time. All right, so this is 3R equals, then we have to distribute 4R, and then 4 times -5 is -20. All right, so I'm just going to, so that's 3R is equal to 4R minus 20. All right, so we're going to subtract this 4R to the other side. So that's going to give me -R is equal to -20. But I want to know positive R. So I'm going to change the sign here and change the sign over there. So that is 20 miles per hour. Okay. Now, they ask, what is the distance? So to get the distance...
Teacher, pardon the interruption. I apologize. Our ag classes today are going to meet
the rate, which is 20, right, times the time, which was 3 hours. So that's going to be a distance of 60 miles. Okay, let's look at this last one. Your cousin renews his apartment lease and pays a new monthly rent. His new rent is calculated by applying a discount of $50 to his original rent and then applying a 10% increase to the discounted amount. What was your cousin's original monthly rent when his new rent is 5% greater? We'll have to get to that question next time.